Thank you for attending today's webinar, The Evolution of Multi-Service Network Edge, sponsored by Juniper. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open on your screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Senior Principal Analyst, Optical Networks and Transport, Sterling Perrin. Sterling?
Hi, thank you, Barbara, and hello. Welcome, everybody, to today's webinar on the evolution of the multi-service network edge, sponsored by Juniper Networks. I'll be the moderator for today, but the heavy lifting for the speaking is going to go to our three presenters today, shown here on the slide. Paul Liesenberg, Senior Product Marketing Manager with Juniper, Truman Joe, Senior Product Line Manager, and then Nikhil Rao, Senior Product Line Manager as well, of course, all with Juniper. So they're going to trade off the duties of presenting the material that we'll be going through. And the flow for the webinar looks like this, kicking off with major market trends, then getting into the new Metro Edge in terms of both requirements for the network as well as some use cases, and then moving to the hyperscaler requirements as well as some use cases around the hyperscaler deployments. And then for the final section, looking at 400 gig plus adoption, which is definitely a hot topic and something I'm quite close to these days myself. And then we'll wrap up and move to Q&A. As Barbara indicated, please do ask questions throughout electronically. We'll gather them up, get to as many as we can. We typically try to have about 10 minutes at the end for Q&A, so please do ask the questions. It's always an important part of the webinar. And the other place where the audience will come in is we have 2 poll questions. Looks like a little bit later in the presentation, but there will be 2 poll questions, so we'd be curious to get your thoughts, and we'll share out those results in real time when we get to those. With that, let me hand things over to, I believe, Paul, you are going to kick this off.
Indeed, I will, Sterling. Thank you very much for the intro. And hi, everybody, and thanks for attending. I'm Paul Liesenberg with Juniper, and of course, I'm going to be assisted by Dr. Truman Joe and Nikhil Rao, who will present their own sections as subject matter experts. I'll just do a brief intro, and then we'll move to the different use cases. The network edge, what we call the multi-service edge in Juniper, it keeps changing. Hence, it needs to always be ready to evolve and to adapt to even more change. And that is critically important because at the end of the day, it is at the multi-service edge where new innovative services need to be delivered in the network and at scale. And furthermore, of course, that is where service revenue is minted for service providers. So as I go through some of these market forces, some are universal and they are on everybody's mind these days, basically. And some others are quite specific to places in the network and use cases. We'll go through both. But let's start by revisiting some of the forces that are shaping markets right now, like continued exponential traffic. We have all heard this. The rates of traffic growth are still mind-boggling in general and primarily driven, of course, by video and gaming at 4K and 8K. But there are other important traffic sources coming up, like machine learning and innovative network edge industry 4.0 applications as well. Traffic growth in the end drives our need to implement faster and faster interfaces. Not so long ago, 10 gig was good enough. Now 100 gig is becoming very widely adopted. And we're even looking into 400 gig and 800 gig, right? As you will see later in the presentation. Remember when 1 megabit DSL was fast enough? Things have certainly changed. Then there's also the whole hybrid workforce movement, which greatly influences, of course, network adaptability requirements. And whatever your adoption model is as a business, you want your service provider infrastructure to support it based on whatever choices you make. And that is a critical role for the multi-service edge as well. And we haven't called it out specifically in these boxes, but I can't emphasize enough how much sustainability and power consumption how important these have become for our customers. In some geographies more than others, but this is something that we need to address, especially as we deliver more and more use cases closer and closer to the very edge of the network with very high service density. Security is important, we know that, so the network has to provide and support ways to thwart the sources of evil. And what we call cloudification is also important, right? Or cloud first. It implies changed traffic patterns, but also demands new adoption patterns, like especially stuff like programmability and cloudified leaf-spine architectures and optimal support for very elastic and flexible service delivery. And also operationally, you look at cloud best practices like orchestration, et cetera. So that's making it into our world as well, quite dramatically. And we could also throw in their supply chain challenges, right? They've been major. It's driven a lot of priorities over the last 12 months, and it's pretty universal. So luckily, it seems that things are easing out there when it comes to that. So let's look at how those driving forces really reflect themselves and how they impact our product strategy as well. How does this impact the network edge in the near future? On the left, you could call it the customer-facing aspect of it. You have traffic growth. We mentioned video at 4K and 8K, new services and traffic patterns like machine learning. We did a very interesting case study in collaboration with MIT just a few months back. But towards customers, it is more traffic, especially more video and more subscribers and more devices. I think the average person now has 5 to 7 devices here in the US. And of course, service providers need innovation and they need to monetize new services, and enterprises in turn need to provide even more complex services internally at faster performance and with increased security. So on the right, which you could call the core network facing aspects of it, we have the demand for increased traffic and the faster speeds of calls, of course, but very crucial in these days of cloud native architectures is we have huge peering demands to SaaS, PaaS, and IaaS infrastructures, and we'll discuss those in a bit. So in a nutshell, we need more service intelligence in the network and at ever faster speeds, which these days tries for 100 gig adoption and even considerations for 800 gig readiness. So this diversity of requirements basically are different for the network core and the network edge, but it especially reflects itself 100% in our latest Trio 6 ASIC capabilities for the multi-service edge, and that's the MX product line mostly. And I'll keep this short because we really want to get into the use cases, but we firmly believe that the required service scale at the multi-service edge is still served best by a specialized newest generation silicon. And I should note that we don't do this because we're into technology religion, because developing silicon is expensive and risky, especially now in the nanometer age. But then again, it allows us to deliver on key design considerations, such as we knew it had to enable very compact form factors because colocation requirements drive that very aggressively. And at the same time, there's a need for power efficiency for the same reason, driven by energy costs in general and emerging requirements as well. I just heard from one of our customers, in fact, that they publicly stated they expect energy costs to surge by $50 million in 2023 for their network operations, which we can all agree is not insignificant. And we need to make systems more sustainable because of those forces. Then there's service intelligence, scalability. They remain an overwhelming requirement as well. And we'll get into those with the use case discussions. And adaptability and programmability are key areas that need to be enabled and for these platforms in the 400 gig and even beyond era. The power of the Trio 6 ultimately means that they represent a Swiss pocket knife for many existing and emerging use cases. I introduced the Trio 6 ASIC. Now let me very briefly talk about the products that the Trio 6 ASIC powers. The Trio 6 is to support high-density service intelligence, built-in security, high speeds, and very compact form factors. And earlier this year, we introduced the MX10004. Wait, I'm on the wrong slide here. We introduced on the MX10004 and MX304 platforms, which are poster children for design priorities that I mentioned. They have millions of queues for hierarchical QoS, check. Very large FIT and RIP table support, as well as tunneling and protocol encapsulation at 400 gig, check as well. The key thing is that these platforms are ready for the future and any emerging use cases. But let our product management experts get into the use case details. We invited Dr. Truman Joe, who leads our MX10K family, as our resident expert on emerging service providers use cases, and take us through those. And then Nikhil Rao, our product lead for the new MX304, will then dive into emerging enterprise, government, and data center interconnect use cases. Let's start with Truman. What do you have for us, Truman?
Great, thank you, Paul. I'd like to start by discussing the evolution of the service provider subscriber access environment. This is a topic which, in and of itself, could fill many hours of webinars. It's a complex discussion based on specific regulatory and business requirements. We'll go over where we are and where service providers want to go, but let me note, excuse me, that this is an open discussion you can follow in many industry forums that Juniper participates in. Before we start, though, I think it's important to quickly introduce the MX10004, which is not just for service provider subscriber delivery, but is also well suited for many network use cases due to its modular nature, compact form factor, high energy efficiency, and scalable network operating system. The MX10004 is part of the MX10000 series of universal edge routers from Juniper Networks. It reuses chassis components such as routing engines and power supplies from the 8-slot MX10008, along with line cards such as the LC480 optimized for 1 gig and 10 gig interfaces, and the LC9600, which is optimized for 100 gig and 400 gig interfaces. Its compact size makes it ideal for distributed scale-out deployments where high throughput with a small blast radius is desired, such as in subscriber access environments. Key features include 400 gig interfaces with MaxX support for 4 line card slots, and redundant critical chassis components such as routing engines, fabric cards, power supplies, and fans for high reliability, high availability. As is true for all MX platforms, it runs the Junos network operating system. But now let's get back to discussing the subscriber access environment. You probably will not be surprised to hear that fixed broadband is driving digital connectivity with billions of consumers and enterprises globally, to the tune of 1.2 billion in the last year. This is a major revenue generator for service providers, but at the same time provides a challenge due to the exponential growth and changing traffic patterns. These concerns can be addressed by bringing services closer to the network edge and protecting it with embedded security. Space constraints found in these environments mean deploying smaller form factor devices with low power consumption and high throughput. The drivers of the growth come from the cloud and software as a service, along with growth of bandwidth-intensive applications such as 4K and emerging 8K video and gaming. Analysts estimate that 80% of traffic today is video, and this is expected to grow at a 55% cumulative annual growth rate through 2030. At the same time, stringent latency and performance requirements excuse me, from applications such as augmented reality, virtual reality, Internet of Things, and industrial automation, for example, motivate service providers to position user plane resources closer to the users to avoid backhauling traffic to a central BNG POP. In addition, providers would like to simplify their operations for cost reasons. In the traditional model, Large, vertically integrated platforms with massive internal fabric are used to support hundreds of thousands of subscribers. In many cases, this creates bottlenecks that increase complexity and costs of engineering to maintain the network. What is needed is a more modular approach to BNG, offering simplified configuration, software releases, and maintenance. This has resulted in the development of the Broadband Forum's Technical Report 459, which defines BNG cups. BNG cups disaggregates the traditional BNG architecture, separating user and control planes, and allowing each to be independently engineered and scaled. This disaggregation makes sense from a purely technical standpoint, as user plane functions have more stringent memory, throughput, and latency requirements. An architecture that lets you position BNG user planes anywhere in the network gives you flexibility to meet changing customer requirements in more economical ways. Instead of always relying on huge centralized service fabrics, you have the option to use smaller, less expensive edge platforms and scale out incrementally with demand. Juniper's new compact adaptable platforms like the MX10004 and the MX304 are designed for this new service delivery world. The use case shown here comes from a broadband provider in the Australia-New Zealand region. They wanted to reduce their total cost of ownership while scaling services and maintaining best-of-class customer experience. The solution was to disaggregate the BNG using cups. The control plane was cloudified, and the user plane, using MX devices, was distributed using a spine leaf architecture. The end result was a reduction of the blast radius from approximately 128,000 to 24,000 subscribers per device, and at the same time, the customer realized a 30% reduction in the TCO. Here we have another use case for a North American service provider for business services. The provider was delivering high-scale and reliable business services using a multitude of devices, using a different device for each service offering. The issue they had was incurring high costs in power, space, and other operational requirements of the network. The solution was to implement a scale-out architecture using a compact platform that could provide multi-service edge functions with high throughput and service scale to lower power and space requirements. Operational efficiency was achieved using end-to-end control signaling with BGP, which provided common control mechanisms independent of the service type. In addition, support for advanced features enabled seamless migration from BGP VPLS to EVPN and from LDP RSVP-based transport to segment routing. Providers have gone through such architectural transformations similar to these use cases many times before, and we know that these take time as there are operational challenges during the transition periods. Juniper makes these transitions easy for our customers as we support all adoption and migration models from the now to the future vision, allowing them to elegantly coexist. Hence, as we have done before, we support these architecture transition models that benefit our customers with best-in-class solutions. So now let's look at emerging use cases outside of the service providers, subscriber access. And we do have our resident expert for many of those here in the form of Nikhil, our expert for large enterprise, government, and hyperscaler requirements. Nikhil?
Yeah. Hey, hi, thanks, Truman. Hi, all. This is Nikhil Rao. I'm the PLM for MX304, and this is great to be part of this session. So what we have been doing is constantly engaging and listening to our customers. The trends have been same. You've heard my friends Pablo and Truman speak of it in terms of what should we be focusing on. The solutions should be optimized for cost, space, and power. These things have not changed. Along with that, what the expectations have been is that there should not be any compromise on scale or performance. Now, adding to this is security embedded. You want security in terms of MACsec or line rate encryption, and also security embedded in the devices to make sure that when these devices are deployed in locations which are not owned by the customers, then the device should be secure. No tampering with the device should happen. And next is rich telemetry. The amount of streaming telemetry that device should offer should be able to troubleshoot the device or understand what is going on in the device. Also future-proof. I mean, the 400 gig is a real requirement, and most of the customers are looking to future-proof themselves with 400 gig. And last but not the least is ready to deploy today. Customers want something that is available with rich feature set. And I think MX304 hits all these boxes and is a huge success already. We see huge demand from service provider, cloud, and enterprise segments for this box. With the 4.8T and also 3.2T with the redundant control plane, I think we have multiple use cases already covered. So let's dive into some of the specific use cases that I've been working on. One of the most complex use cases is the virtual private cloud use case. We all understand, and we have been discussing this in this session and also previously from a very long time. Hyperscaler growth is driven mainly by workload migration from on-prem to cloud. But what do you see going forward is some of the new things that cloud is trying that will actually increase the traffic threefold or fourfold. Services such as WAN cloud services that leverage the backbone of the cloud for connecting different office locations. I mean, you already are connected to the cloud. Now you could actually leverage those connections to consider the cloud as your WAN backbone. I mean, this will mean there will be more traffic. There will be more traffic passing through the cloud, entering and exiting it. And also we have enterprise 5G use cases. So the amount of traffic entering and exiting cloud is going to increase. So the focus on how we monetize this and how we help our large hyperscaler customers to achieve this in the best way is what we're trying to talk about today. Today, the large hyperscalers already have hundreds of MXs in their network. It is critical for them to provide direct connectivity to their large customers at high speed, in a reliable and cost-effective way. The focus has been to deliver services in a reliable and cost-effective way. That's what differentiates these services from the traditional services. For this specific use case of VPC Edge, let me break it down further. VPC Edge, the virtual private cloud, is a specific role that is used to terminate many customer circuits at very high logical scale at the periphery of the network. This is where the customer enters the cloud network, if you could say, right? I mean, in this diagram on the right, you can see that the CPE devices connect to the VPC Edge. This is where you hand off from the customer to the network of the cloud. And there are many ways of solving this. You could have a mesh network connecting all the devices together, but that will be extremely expensive. So what has been working and where MX has made a difference is enabling cost-effective ways of doing it. Large tunneling and queuing scale of MX combined with already the cost and power profiles and feature set is driving some of these designs. Let's look at what design options were provided to our cloud customers to solve these problems with MX. Basically, the peripheral edge, that's the VPC edge, could be a high-scale edge router that processes traffic in a customer-specific VPN context, right? Forwards the traffic between the data center and the customer network. This design is already being deployed by many. Actually, we see in one of the hyperscaler designs today, the VPC edge, that is, you call it VPC edge, VPC gateway, or peripheral device, is already aware of the specific virtual network location and hence sends the traffic towards an intermediate data center gateway, which forwards the traffic to the specific virtual machine. This is already being deployed. Another way of doing it is that the virtual machine location information itself is present in the VPC gateway, and no intermediate device is required. This way, VPC gateway has full information of of the virtual machine and what encapsulation is supported, and this can be used to directly connect and provide traffic to the customers. VPC gateway today needs to understand the exact same encapsulation that the server provides, thus eliminating the need of intermediate devices. Other than the features and complexity we spoke of, what is most important is the cost per customer and cost per bandwidth, and also power consumption. Power consumption and cooling per device and per rack is imposed by the exchange facilities in which the locations are provided. Not all the VPC edge locations are owned by our hyperscalers. They could be positioned in POP locations which are owned by colos of the world. The focus has been and will continue to be on reliability and cost. And that's why I think MX304 hits most of those points. Maybe to summarize where we feel that MX304 has made a difference in this use case is that many customers today are looking to deploy 400 gig for customer-facing circuits with full max-ACK. And increasing availability of 400 gig is accelerating this transition. So MX304 with feature encap, tunneling features, cost, inline max-ACK, power profile seems to be a very natural fit for this. So we do see that this transition picking up pretty well as well. And second is something interesting design choice that we did with the device that allows us to configure the MX304 in 1.63, 1.6T or 3.2T with control plane redundancy of 4.8T. So that means that you could use the same device in different shapes and sizes. That will bring down the cost of sparing, onboarding the device, testing and certification. So overall lower TCO as well. So along with our already proven reach feature set and compact and power optimized solutions, I think this is naturally going to fit in pretty well for these use cases. So moving on to the next use case. Sorry, I'll move on the slide to enterprise use case, right? I mean, now when we speak of enterprise and the cloud, they're pretty much connected because I think most of the enterprises are moving their workloads to the cloud. Now, enterprise solutions are getting more and more complex. You have multi-cloud, hybrid cloud, and increased work from home options that are posing challenges to how enterprises have to think of their solutions. And what is relevant today may not be relevant in maybe next 1 or 2 years itself, right? We already have challenges with oversubscribed WAN links. We have cyber attacks leading to security and strong DDoS protections. I mean, this is one of the #1 things in mind for all the enterprise CIOs. And I think the end user experience is extremely important for the enterprise customers, right? I mean, enterprises are thinking of themselves as service providers with the end users being their customers. So the way enterprises are now considering the network designs is different from the past. And also, enterprises must build networks that caters to exponential bandwidth growth over the next 5 to 10 years. So in this slide, I want to focus on some of the complex use cases, that is Internet Edge. But before going into Internet Edge, let's see what are the different WAN solutions that are already there today and how MX has been already deployed there, right? I mean, we already have the enterprise WAN aggregation and backbone. This is basically interconnection of multiple types of enterprise locations. I mean, you can have your branch, headquarters, and data centers connected. That's the enterprise WAN aggregation and backbone. The Internet Edge. The Internet Edge is an interesting use case where I think interconnection of enterprise WANs to one or more service providers, allowing access to users to the internet and also external corporate resources. This is getting more and more complex and diverging because of the way internet is consumed today. This clubs into the next use case, that is the enterprise multi-cloud. The interconnection between applications and microservices across different cloud platforms is actually adding a lot of pressure on how do you design the Internet Edge as well as the enterprise multi-cloud connections, right? And last is the data center interconnect. I mean, data center interconnect is the connection between enterprise data centers that enables resiliency, like your availability zones, if you could say so. Of all the 4 use cases that I spoke of, enterprise WAN, Internet Edge, enterprise multi-cloud, and DCI, we have already MXs deployed today. And maybe focusing on the Internet Edge, what we are seeing is that the Internet Edge is evolving because it is not just used for backhauling the traffic to the company headquarters to enable security services like URL filtering, anti-spam, and IDF, but also considering that for now using it to connect to the cloud, right? I mean, how do you consider enabling your existing infrastructure to work with multiple cloud and multiple internet service providers. What is most important now is to enable services like extremely high load balancing and filtering for DDoS protections. So having these edge devices to be able to support filtering and sometimes encryption like MACsec is a high requirement today. And I think the ability to start small and having different form factors is also helping this this solution. So basically, if you take a step back and consider what enterprise solutions should offer is improved operational efficiency, increased flexibility and value of investment, security, and cloud-grade reliability. And I think 304 and even 10,004 that way is proving to be a great fit for these use cases. We already have MX proven with rich feature set and DDoS protections, with high filtering, granular policy, and telemetry. Also, there's encryption support. And moving from 10 gig connections to 100 gig with future proof of 400 gig is something that we feel will help our customers to move forward with the journey. So yeah, with these two use cases, I hand it back to Paul, to take us forward. Thank you all.
Hey, actually, I believe we have a poll question next. So I will run us through the poll and gather up the audience responses and push them out and let you guys comment on the results. This one is about the different use cases between Truman and Nikhil. We've gone through a number of use cases, so this is a set of them. The hybrid. So this is which is most interesting to you. I believe it's multi-choice. It should be hybrid multi-service edge. The BNG, control user plane separation, CUPS migration, the hyperscale data center deployments, or the 400 gig support and 800 gig readiness. So between the two speakers, they covered that full set. Give you a moment to pick the ones that suit you, and I'll push them out, just waiting to get kind of a critical mass here. While I do that, I will remind, just looking at the clock, we are definitely going to have a lot of time for Q&A, which is great. If you do have questions, please start asking them now. It's always a little easier than waiting until the Q&A begins. But ask away now, because we are going to have time for that. Let me push the results here. And this should show on everybody's screen. The hybrid multi-service edge, 53%, followed by about 26% the 400 gig and 800 gig readiness, and then a little bit behind that, actually a fair amount behind that, the hyperscale. Interesting that the BNG got the least amount of traction. Let me just do one more push, and I'll let I guess both Truman and Nikhil, if you want to comment. Truman, start with you, and then Nikhil, if you have additional comments you want to make. But any surprises? Is this how you expected the results to come in, Truman?
I'm actually a little bit surprised. I thought that there would be a bit more traction in the BNG control user plane separation migration, because in terms of our customer interactions, we certainly see a lot of interest there. But perhaps given the topic of this webinar, it might have skewed it a little bit towards the first category. But yeah, so I am a little bit surprised.
Yeah, that actually is a good comment. If you look at the title, we do have kind of it self-selects the subset of people. So, I mean, I guess it's a good thing the right audience is tuning in, because that hybrid multi-service edge is the top one. But you're right, this may not reflect the overall population of operators globally. Nikhil, any thoughts on the ones related to your use cases?
Yeah, I think maybe Truman mentioned it well. I would have also thought BNG and maybe hyperscaler data center deployments would have been higher. But this is not a surprise, considering that how multi-services edge is evolving, right? I mean, how do you want to see the future? How do you want to probably differentiate? And yeah, I think mostly it is based on the audience and the set that we have.
A snapshot of who we have. Great. I believe we've got another slide of content and then another poll question, and then we'll get into the Q&A. I'm not quite sure who was taking this one. Was it Paul?
I can do it. Yeah. Okay. I'll take it over. And yeah, it was an interesting poll as well. I would have expected also that hyperscale would have ranked quite higher. But yeah, I guess, like you said, the titles of the webinar probably self-select. So thanks, everybody. And let's wrap this up briefly before we go into the Q&A. And I hope this answered questions about the future of the multi-service edge. It is growing in importance, that's for sure. It is increasingly strategic to deliver on new services and monetization, of course. And commercial plug-in here, the MX family is now enriched with the capabilities of the 306. Here and now, it's highly adaptable. We can't entirely foretell the future, of course, but we're ready for it through programmability, power efficiency, and with these new compact factors that allow us to deploy these powerful devices pretty much anywhere. So we're ready for things coming our way. One thing I want to mention, you see here, we mentioned 400 gig optimized and 800 gig ready. So we touched on this a couple of times, and that is a great discussion that also deserves a future webinar all by itself, just like BNG Cups. But a few words, we do indeed have customers that have already taken advantage of our 400 gig interfaces. Of course, we do that. And that said, for an important part of our customers, 400 gig at the very network edge, like here, is where they want to be ready to go soon, but as their particular business needs require, and wherever they require it. Not all customers yet, but it is a key strategic consideration for future-proofing their network investments. And as to 800 gig, we can give away any roadmap information, but it's definitely on the technology horizon, and we'll see adoption patterns very much like the ones of previous generations, right? Where architectures are ready for it whenever the use cases we discussed demand it. And the key message is simple again, 800 gig ready. But I think the next poll could be interesting as well, if we can move on to that one.
All right. Yep. Yes, so our last poll question is on the 400 gig. When do you expect 400 gig deployments? And I mean, I guess that's really the question. When do you expect the 400 gig deployments? Now, 16 to 18 month window, so 6 to year and a half out, or 19 to 36 month window, so the next 3 years. I guess if you don't expect them at all, you probably put probably don't answer. We probably should have put a further window, but 3 years is quite a bit of time. So of those three, pick what suits you best, based on if you're a service provider for your own, or if you're a vendor or someone else in the ecosystem, serving the service providers, based on your own interactions with customers. We'll give a minute for those results to come in, and we'll do a push. Let me just push here and see what it looks like. Let me do one more. So interesting. Let me do one last push and see if we changed. Doesn't look like it. Yeah, again, it's a slice of the audience we have. In terms of who we have on, none saying right now. 60, and then pretty well about it is even split as you get of the two options, 50-50, 6 to 18, and another 50%, 19 to 36 months out. Let me do one last push and see if it changes. It is not. Paul, since you just presented, maybe let you weigh in first, and if the others want to comment as well.
Yeah, I find it interesting that nobody said now. I would have expected at least one person to vote for now. And yeah, I think these adoption patterns are pretty typical. If you look back at adoption patterns like over the history of interfaces from 10 gig, 40 gig, 100 gig, 400 gig, it's typically like this time span that you have where first of all, like very large customers, mega data centers, and very large service providers drive the business case, but there's few deployments, and then over time, the entire market catches up. And of course, it's also a pricing question at the end of the day, where initially these devices are going to cost the cost per port is going to be much higher. And then over time, the cost per port actually decreases and more people adopt it.
All right. Yeah. Any Truman or Nikhil? I don't know if you had any comments on this. If not,
yeah, I know. Just a quick comment. I mean, I'm a little surprised that nobody said now. I mean, there are deployments we know of that are going on in 400 gigs. So the fact that we had none is a little surprising. But otherwise, you know, the results, the even breakdown between the upcoming 18 months and 36 months. I mean, it does take some time to roll out new technologies, and customers do tend to roll these out at different time periods. So we see that kind of behavior. So I'm not that surprised that there's an even breakdown there. I'm just surprised that there's nobody saying it's now.
Yeah, the only thing I would say on that is it would be reasonable to assume the hyperscalers, the big ones, are driving the initial deployments. Our audience probably wouldn't represent them too well. We tend to draw heavily from the telecom, so this is kind of, you know, traditional telecom of large size, but more of a telco audience than you know, the Googles of the world. So
that makes sense.
I think adding to what Truman said, right? I mean, we are aware of deployments that are like either now with the boxes that we have shipping that's being planned and already tested. So yeah, maybe. And other thing is, right, I mean, this is not just core, right? I mean, we are seeing 400 gig to the core, but what we are seeing with some of the new boxes is that 400 gig towards the customer. That's something that is pretty interesting, right? I mean, we spoke of that, one of the use cases for the virtual private cloud segment. So the core is something that we all understand for 400 gig to the core, but what's interesting and what is driving more interest is some customers asking 400 gig native with MaxSAC capabilities turned on. So that's the kind of traffic growth that we are seeing. So yeah, interesting.
All right, let us, I believe we move right into the Q&A from here. We do have some questions, so I'll jump in, and again, for the audience, if you've got any additional questions, let us know now. Truman, I'll start with you, and then, of course, if somebody else wants to comment, you may. But the disaggregation, the BNG cups use case application that you walked through, question about, you know, you addressed it a little bit, actually, in the poll question, but maybe a bit more detail in the market traction that you are observing, and any thoughts or recommendations that you have around that. You know, I don't know if you can name specific customers, but types of customers, regions, any kind of detail on how you see that being deployed and where.
Yeah, I can't obviously name specific customers, you know, NDA agreements and all that. But I will say that there is actually very good traction in the BNG cups. Much like the use case that I presented here, there is actually a customer that's already deployed this. We have deployments basically worldwide for BNG cups. Quite a few are looking at it, qualifying it, you know, making that decision. I would expect that there will be quite a few major customers moving in that direction, and a good percentage of the market will end up there just because of the advantages that BNG cups provides, the scalability aspect, the lower cost of ownership, the ability to leverage the control plane separately from the user plane being optimized in the hardware. I think all of these are just very good benefits of that model, and I just see that from a cost standpoint, simplicity of the model, the ability to leverage smaller boxes, which makes it a bit easier to manage. I see many customers moving in that direction, and many have already moved in that direction.
All right.
I'd add something to that, and it's everything that Truman said, of course, but we should also keep in mind that any successful architectural migration, it takes some time, right? And while you're engaged in that change, you will invariably have to support a hybrid transition architecture. And I think it's a great help for our customers that we do that very effectively, because we cover every type of architecture out there.
Great. There's a question around automation. I think, Paul, maybe start with you. And again, if anybody else wants to add to it. It references some comments made in the presentation around automation, and they're looking for more detail in terms of what are the tools involved, the software that's involved in automation, and maybe just to add on that a little bit to where are you seeing the biggest traction with automation?
Yeah, automation is a huge discussion all by itself, and we have done a few webinars. The products we're discussing today fit mostly under the Paragon automation umbrella, if you look at our product offerings. But automation is also one of those things where, different customers also have very different goals when it comes to configuration, to management, to security or troubleshooting. So in general, I would say if you're interested in automation, check our Paragon page on the Juniper website and stay tuned for webinars because it is a very hot topic indeed.
Did anyone else want to add to that question? If not, I'll go to the next. No? All right. Question on power consumption. And I guess maybe two parts to this. One is the question is very specific to the power consumption on the product lines that are being discussed. And I would add to that, to maybe even broaden this out a bit. I'm curious how important power consumption is in your discussions with customers across both, maybe for Nikhil and then also separately for Truman in terms of the priority. Just for a little bit of context, I'm in New York right now. We did our 5G transport event yesterday, and one of the comments that came up, we didn't have a lot of discussion around power consumption and kind of green and sustainability. And a comment was made that if the event had been held in Europe, probably would have been a higher priority. So I'm just curious, I guess, too, the specifics about the consumption on the products, but two, also how important that type of metric is, and does it vary by region? Just out of curiosity. Maybe Truman, start with you, and then we'll go to Nikhil.
Sure thing. To put it very simply, I think power consumption is a very important attribute. This is something that I find many customers ask about. Many customers have it very high on their priority list, and I think rightfully so. I think as good stewards of the planet at one level, we want to make sure that products are sustainable, that power is used as efficiently as possible. And there's a very real cost to it as well for customers. Power is not inexpensive, and the cost of power is going up. Energy costs are going up. This results in a very real impact to operational expenses for a network. Depending on the size of your network, the power bill can be in the hundreds of millions of dollars. So it's very important that there's no way around it. Almost everybody asks, almost every RFP I've ever seen asks about it. So it's very, very important in my mind. I think everyone does care and probably should care. If they don't care, they should care. In terms of more specifics, though, I mean, one part of the question that you mentioned, Sterling, was the power for the 10K product line specifically. That's a hard question to answer in a general Q&A because the power consumption, of course, will depend on the exact configuration, the traffic you're running, the environment you're running in. So please take what I say with a grain of salt, and I will disclaim it by saying your mileage will vary for sure depending on your environment. But typically on an MX10004, which was the product that we had mentioned in this presentation, with a couple of line cards configured in sort of a typical traffic load, let's say 50% traffic running through the box at sort of an internet mix, I think you can expect to see something in the order of 3,000 or 4,000 watts of power being consumed by that box. But again, can't stress enough, your mileage will vary. It really depends on configuration, traffic load, etc. So,
All right, thanks for that. And Nikhil, same kind of two questions, the specific and the general for your product set.
I think when you pay directly to the power bills or when you pay the co-location owners, there's a difference, right? I mean, these boxes are going to co-locations, and power and space is like the most important thing that we have, right? I mean, obviously you need the feature set, but the amount of power savings translates to real dollars, double the value, basically. So, and there's also restrictions on how much of power you can put in per rack, right? So how do you design your per rack? Not all locations have 10, 15,000 watts coming to each full rack. So if you want to have consistent designs and if you are constrained by the total rack, I mean, power is important. Every cloud customer I speak to, first, we start with the power number and then go back. That's how one of the design decisions are taken. Cost and power is extremely important. So, I mean, I think power is like number one ask at this point from our hyperscalers. Yeah, and in specific geos, we are seeing request more compared to some of the other geos, as you mentioned, right? Initially, the event was in North Americas, and if it was in EMEA, it would have been a different thing. Yes, we see that very much. And there is more and more questions on what will be the exact power at the particular amount of traffic and all this. That's what Truman alluded to also. I think the question now is that we are seeing interest in specific customer deployments also. Earlier, you had a data sheet that would tell you what would the power look like. You'd add some plug optics or maybe overall basic numbers. But now everyone wants to know specifically at my usage, at my temperature, at my altitude, at my traffic mix without MaxSack, how much of power it is. So those scenarios have changed, and we see more questions in those areas. And just to add, I mean, if you're looking for, working with hyperscalers, and if you're looking for a box that has control plane redundancy, that does 3.2T with basic 50% timings traffic, we're looking at 1,200 watts. And this is driven by, again, one of the latest generation silicon, right? I mean, because it's 7 nm and it's power efficient, we're able to provide better efficiency in terms of power.
All right, excellent. I appreciate that. Yeah, and good comments. I expected that given the hyperscalers, you would say power would come in at number one, and I think it's a very accurate comment about the colo. I hear that myself quite a bit when it moves to the colo world and you're paying for that power. And it's very expensive in these data centers that it becomes, sustainability environment is of course important, but there's also some very hard dollars and cents that come in. With that, we are pretty close to the hour. We've had kind of a lengthy Q&A session, so let me close it out here. I want to thank all three of our presenters today for your comments, your presentations, and answering our questions, and of course, thanks to Juniper for sponsoring, and thank you to the audience for tuning in. We'll close out here. Thank you, everybody.
It was our pleasure. Thank you so much.
Thank you.
Thanks, everyone.